All right, so hello, and so welcome to our last topic of the unit. So before we get there, I do want to go over one question from the homework because I know it might have been a little bit challenging. And so that was number 5. So it's the unknown compound. So if we look here, what we have is that I gave you the formula. It was x2y6. So these are just made up elements. And the information I gave you was that X is in group 4A, so group 4, and then Y is in group 7A or group 7. So remember what that tells you, okay, is that X is going to have 4 valence electrons, and then Y is going to have 7 valence electrons. And so all that does is that tells you, so like every atom we have of either X or Y, it tells you how many valence electrons it's going to have. So there's a little confusion, I think, about, like the 2 and the 6 over here. Like, how could we have something in group 7, but then have a 6 next to this Y? So remember that this is giving you different information. So the fact that Y is in group 7 just tells you that every atom of Y has 7 valence electrons. The 6 here tells you that in this molecule, there's 6 atoms of Y. All right, so again, the amount can change here. So we could have a molecule with 100 atoms of Y. All right, so all the group information tells you is just how many valence electrons each atom has. Okay, and so again, what you want to do is how you start all of these is to draw the Lewis symbols for what you have. Okay. So I'm going to draw my 2 X's here. And so remember that X is in group 4, so it has 4 valence electrons. So I'm going to write them as single dots in each of our 4 locations. Okay. And so now I have my Y's. So I'll do them in a different color. So I'm not going to draw all 7 of them. Okay. But they have 7 valence electrons. And so here is how we would write that. Okay, so remember, we're going to pair up on 3 of them and then leave a single electron on whatever 4th location you have. Again, it doesn't matter where you put the single electron as long as it's at least in one of these 4 locations. So remember that there are 6 of these. Okay, so we'll just say times 6. And so remember, what we want to do is we want to look to see how we can get rid of single electrons. We want to look to see how we can pair up those single electrons. So X is in group 4, okay? So that's the same group that carbon is in. And so if you remember when I talked about carbon, carbon always goes in the middle, okay? And so just like carbon, since X is in group 4, we're going to say, all right, we'll just put it in the middle. Another way, if you didn't make that connection, is you can think about, okay, well, whatever we're going to have more of is going to be on the outside. So like if we tried to put 6 Y's in the middle, we're not going to have enough X's to go around them. And you can think of it like that, okay? So the things we're going to have less of are going to be in the middle, all right? So again, we want to draw in what we have. Okay, so each of these X's has 4 valence electrons. And so since we have 2 of them and they're both in the middle, we're going to hook them together. Okay, so we're going to hook them together right here. And so what that's going to give us is this. Okay, so we have 2 X's connected, and then we still have, 3 valence electrons on each of them that act as single electrons. So now we have 2 electrons that are being shared in the middle here, so we got rid of one of our single electrons in each of them. So now we can look and be like, okay, well, there's still 6 more locations where we need to pair up our electrons. Well, luckily for us, we have 6 of Y, because each Y has a single electron as well, right? This one. And so all we're going to do is we're going to take each of our 6 Y's and we're going to put them at each of these 6 locations. okay? So what you're gonna end up getting is something that looks like this. So again, sometimes these things take a while to draw because there's so many atoms. So I won't give you like too many of these on the test because I know they take some time. The other thing is that I've noticed is that some people haven't been putting in, remember these are called lone pairs. So these are electrons that are on the atom but aren't bonded to anything. We still want to draw them in, okay? So even though it's kind of a pain, we still want to show that we have those electrons. Because remember, if we don't draw these 6 electrons, these 3 lone pairs on each Y, it's like the Y only has 2 valence electrons. Okay, remember that the Y wants 8, just like our X does. Okay? And so this is what your like final answer would look like, okay? So it would be like this. So what this shows us is that each X, okay, is bonded to the other X in the middle, and then its other 3 locations is bonded to a Y. Okay, and what you'll see if you go through and count these up is that this fulfills the octet rule for each of these. All right. And so if we go and look at what we're going to talk about today, so everything that I've shown you so far only uses 2 electrons for every bond. Okay, so I've given you a single electron that we want to pair up, and you found out where the other single electron is, and you've tried to match them somehow. Okay, so we've only worked with single bonds. Well, in reality, there's 3 types of bonds. Okay, there's single bonds, there's double bonds, and there's triple bonds. All right. And so where we're going to use these double and triple bonds are when I give you a molecule where you're trying to put it together with single bonds and it just doesn't work. So what I mean by that is you're trying to put it together, you're trying to fulfill the octet rule, and you're still seeing single electrons somewhere. Okay? So your single bonds aren't doing enough. Okay? You need to add in something a little bit more advanced. And so this is why we're going to call them complex structures. So what we're going to call complex is something that has more than just single bonds. So something that has a double or a triple bond. And again, we're going to use these so that we can get 8 valence electrons on each atom. And so here are just some visuals about what this actually looks like. So the first 2 up here are just like our normal Lewis symbols. Okay, so this is kind of the progression of difficulty. So at the top, we're like, okay, we're just drawing the symbols. All we do is we just indicate how many electrons they have. And this is what you've been doing so far. So this was actually one of the examples. This is water, okay? So we saw that, all right, it forms single bonds with hydrogen, and then it has lone pairs. So remember, it's a single bond because there's just 2 electrons. So what we have down here are a double bond and a triple bond. And so this double bond is occurring between these 2 carbons. And so what you see is that there's 4 dots in here now, as opposed to just 2. So like if we looked up here, there's 2 dots between the oxygen and the hydrogen. Down here, there's 4 dots, okay? So they're sharing 4 electrons. A triple bond is the same in that it's a bond between atoms, only it just has 2 more electrons than a double bond. So a triple bond is sharing 6 electrons. So in this case, between the 2 carbons, they're sharing 6 electrons, all right? And this other column over here is something we're going to talk about a little later. This is known as a structural formula. You might notice that, okay, they're just replacing these dots with lines. All right, so that's the difference between a double and a triple bond and a single bond. So a single bond has 2 electrons, a double bond has 4, and a triple bond has 6. And so what we're going to do is similar to what we've done in the last couple presentations is that I'm going to go through some examples. And so this first one is going to show you what I mean by, okay, the single bonds isn't enough anymore. And so if we look at this, we have CH2, okay? And so I'm going to go through, I'm going to draw everything that I have just like usual. So I have carbon, which has 4 valence electrons. I have my 2 hydrogens, okay? They each have 1 valence electron. And then I have oxygen, which has 6. And so if you just look and you're like, okay, well, we know that carbon goes in the middle, so we'll start with that. And you're like, all right, well, I know that hydrogen always goes on the outside, so I'll stick my hydrogens on the outside. Well, I only have 2 of them, so I can only put them in 2 locations. And so I'm like, all right, well, I've gotten rid of 2 of our unpaired electrons on carbon. I still have 2 more, and all I have left is a single oxygen atom. So if I just did what we have done so far and tried to put this oxygen here, we have a problem. And our problem is that notice there's still 2 unpaired electrons. Okay, so we don't have any more atoms here. We've used up all the atoms we have, and we haven't paired up all the electrons. Another way to think about it is if we look at this and we're trying to fulfill the octet rule, the carbon only has 7 electrons, and so does the oxygen. Okay, so the reason why we don't like this is because we haven't fulfilled the octet rule. So this is where we're going to need to form a double bond. Okay, and so what you're going to do is you're going to look to see, okay, where do I still have those single electrons? Well, I have one here on the carbon, I have one here on the oxygen. So we're going to move each of those into this bond between them. Okay, and so how that would look after I do that is like this. Okay, and then we would still have our hydrogens on the outside. So this is how we would draw this, because now we have this double bond here. Okay. So here is our double bond. Again, now if we look, we're sharing 4 electrons. So this carbon has 2, 4, and then plus these 4, 8, so it's happy. And now the oxygen has these 4, okay, as lone pairs, and then these 4 that it's now sharing with the carbon. Okay, so now it's happy. And again, the reason why we did this is because over here, before we made the double bond, all right, we still had single unpaired electrons. All right, so let's do another one. So here is S2, all right? So what this tells us is that we have 2 sulfurs. And so if you remember, sulfur is in the 6th column, so it's going to have 6 valence electrons. And so we have 2 of them, so I'll draw them in different colors. And so again, if we just try and do the same thing we've done so far, and we're like, okay, try and match up my unpaired electrons, we can hook the sulfur together with a single bond like this. And you're like, okay, well that isn't any good, because if you look at this, both sulfur has 7, so both of these sulfurs have 7 valence electrons, okay, and they want 8. And we have these 2 unbonded electrons here. And so just like last time, what we're going to do is we're going to look to see where they are. Okay, well in this case we only have sulfur, so we're going to move each of these into the bond that we have between those 2 atoms. So what this is going to give us an extra S there, is this. Okay, so this would be your final answer that you would put, because again, here we have our double bond, which again we needed in order to fulfill the octet. All right. So again, when we're going to use these double bonds is when we have this type of situation where we're trying to just do single bonds and it doesn't add up, it doesn't pair all our electrons. Okay. So now we're going to move on and see a different example, which is N2. So if you look at the periodic table, N is in group 5. And so each of these N's has 5 valence electrons. So if I again, try and do what we did the other day. I can hook them together, all right, with a single bond, but now I look and I still have 2 electrons on each of them. So each nitrogen atom still has 2 electrons that are unpaired. And so this is where we're going to bring in that triple bond. And this one can be a little bit tougher to see because we're going to move our dots a little bit farther. So what we're going to do is, if you remember, a triple bond is 6 electrons being shared. Okay? And so we have 2 right now, and we have these 2 unbonded ones on each of our nitrogen atoms. So we're going to end up moving every unbonded electron into this bond between these 2 nitrogens. And so how that would look, and I would go ahead and try and draw it for yourself before I draw it to see if you can do it. Is in the end, you're going to find that you have something like this. And so I know this might look a little weird, okay? But if you look, again, this satisfies our 6 electrons, our triple bond. Because now we're sharing these 6 electrons, and then each of these nitrogens still has a lone pair, so they each have 8 valence electrons. So this is when we would need a triple bond, okay? When we have multiple unpaired electrons on each atom. All right. So we'll do our last example here, so CH2S. So I think the trickiest ones are the ones that have more than 2 elements, okay? And so I have carbon again. I have my 2 hydrogens again. I have my sulfur. All right, so that's, again, how each of these Lewis symbols would look. And so I want to go through, like I've done before, and try and pair them up. So again, that carbon always goes in the middle. Okay. So I'll start by putting it in the middle. My hydrogens always go on the outside. So I have 2 of them. So I'll stick them in 2 of the locations. And now I have my sulfur. So I'm like, okay, well, there's 2 places where I'm unbonded, so let's choose one of them and combine it. So hook it up to that carbon. And that gives me this. Okay. So then what you'll notice is that this looks very similar to our first example in that we have single unbonded electrons on each of them. Okay. So in this case, since there's just 1 unbonded electron on each, this is going to be like a double bond situation. So if we just move each of these electrons into that bond between the carbon and the sulfur, we'll get this. Okay. So again, just for time's sake, I drew it all in the same color here. But some of these electrons would come from, the hydrogen, some would come from the sulfur. Again, we're doing covalent bonding, so we're sharing. The important thing is that you recognize that you need the double bond here, okay? And that everybody has an octet and hydrogen has 2. All right, so this would be your final answer. All right, so just like the last couple of days, there is a worksheet for you to try it out on. So definitely let me know if you need help. This can be pretty challenging. So go ahead and try that for yourself, and if you need help, I'll be around.